This is question number 9B from May 2025 question paper. In smart irrigation system, sensor monitors the parameters like soil moisture, soil nutrients, humidity, temperature, etc. The data is recorded in the system and historical data can be viewed whenever required using cloud. In order to design this system, what are the components required, and if the system behaves improperly, then how do you test and troubleshoot to make the system functional? So in this question, they have asked to write the components required for a smart irrigation system, and for that 4 marks are allotted to write the components. And how do you test and troubleshoot the system? For testing and troubleshooting, they have allotted 6 marks. So first you should write the components required required for the smart irrigation system. So before that, what is smart irrigation system? Smart irrigation system, it is an advanced method of managing water supply for agriculture. That is the meaning of smart irrigation system. Okay. Then uh, in this smart irrigation system, um, suppose it is used in a form, it uses a soil moisture sensor to detect when the soil is too dry, or if the dryness is detected, the system will automatically opens the solenoid valves to water the plants and then closes when the right moisture level is reached. So all this is done without any human intervention. So this is the definition of smart irrigation system. It uses many sensors to detect the soil condition. So after detecting the soil condition, whether to open the solenoid valve to water the plants or not to open the solenoid valve to water the plants, that is decided. The benefits of this smart irrigation system are it saves the water and energy, and it increases the crop yield, and it reduces the manual labor. So for this question, no need to write about the definition of smart irrigation system. Directly, we can start with the components. The components, if you are not able to recall the components in examination, if you remember this block diagram, you can explain the entire question using this block diagram. So for the components required are power supply. In power supply, you can use solar panels or a battery, and microcontroller. You can use Arduino board or ESP32 board or a Raspberry Pi. And here sensors are used. One, two, three, four, five blocks: soil moisture sensor, soil nutrient sensor, temperature sensor, humidity sensor, and flow sensor. So all these things are the sensors. And input side, there is a sensor. Output side, there should be actuators. Actuators are the output devices, and sensors are the input devices. Actuators, you can use the solenoid valves or water pumps. And finally, the irrigation pipes in the output side. And in order to communicate between the sensors and actuators, we need the communication module to send the data from sensor to actuator, whether the open wall should be open or closed. So that command is given by this microcontroller, and to give the command or to collect the data, we need a communication module. You can use Wi-Fi module, you can use LoRa technology, or you can use Zigbee. So we need cloud storage also in order to store the data on Firebase or Amazon Web Services or Azure. And in order to visualize the data, we use dashboard. So these are the diagrams. The first, mainly we need power supply. After that, we need microcontroller. We need sensors, all these 5 sensors. We need actuators, and we need communication module and a cloud. So now you can list easily. If you remember this diagram, just list the components. The components required are sensors. What are the sensors we used? Soil moisture sensor, soil nutrient sensor, temperature sensor, humidity sensor, flow sensor. So what controller you are using? You are using microcontroller, Arduino board or ESP32 or Raspberry Pi. Then what is the communication model you are using? Wi-Fi, LoRa or Zigbee modules. Now, which actuators you are using? Solenoid valves and water pumps. And what cloud you are using? Cloud and dashboard, Firebase, AWS with user-friendly dashboard. And what power supply you are using for a smart irrigation system? Solar panels or a battery backup. The same diagram we have listed in the components. So this is about, if you write these things, you will get 4 marks. So better you should write one line for each component. If you remember, or if you can write in your own sentence. Sensor, soil moisture sensor. What is the use of soil moisture sensor? It measures the water content in the soil. So how much water is present in the soil is determined by the soil moisture sensor. It measures, not determined, it measures the water content. And soil nutrient sensor, it analyzes the nutrient levels. How much fertilizer should be given for the plant, that is decided based on the nutrient levels. Temperature sensor, it measures the ambient temperature to adjust the irrigation time. How much should be, how much time the water should be given to the plants. So the time is decided by the temperature sensor. Next is humidity sensor. It will track the atmospheric humidity in order to influence the watering cycles. Whether to water the plants once in a day or twice in a week. So that is decided with the help of the humidity sensor. Flow sensor, and it will detect the leakage, or it will detect the blockage by monitoring the rate of flow of water. So this is all about the sensor. Next, microcontroller. So microcontroller, or we can also say processor. So it acts as the brain of the system. So what is the function of this microcontroller? It processes the sensor data. It gets the data from the sensor. It processes the data, then executes irrigation commands. Whether to open the wall or whether to close the wall, that commands are given by this microcontroller. So communication module, Zigbee, LoRa, Wi-Fi, Bluetooth, they can be used to transfer data between the sensors and cloud servers or the mobile apps. So actuators and the solenoid valves automatically open or close to control the flow of water based on the sensor data, and water pumps move water to the required sections of the field. Cloud storage, why it is used? They are used to store historical sensor data for monitoring, for analyzation purpose, for later analyzation. And the data can be stored in a cloud. And dashboard, it provides the real-time data visualization. We can see the data in a real time using the dashboard. Power supply, in order to give the uninterrupted system operation, we need the power supply continuously, especially in remote areas. So using solar panels and rechargeable batteries. And additional components, if you want to write, you can write LCD or OLED for display purpose. Live sensor values, you can see relay model, because pumps and valves, they need a high power to turn on. So relay models are used to switches the high power components like pumps and valves, and SD card module to store the backup of the sensor data. Real time clock, it maintains the accurate time for scheduling the irrigation. Then next question is testing and troubleshooting for 6 months. How do you test and troubleshoot the all the components? So sensor, first we should check the sensor accuracy. How to check the sensor accuracy? We should first verify the readings using manual tools. We should use a traditional soil moisture meter, or we should use the traditional thermometers to ensure the sensors are providing accurate data or not. So first we should check with you check using the traditional method, and those values we should compare with the sensor value, and in order to verify the readings. And you should clean and inspect the sensor connections for corrosion, whether corrosion. We keep all the sensors in a soil, so we should check sensor connection for corrosion or dust or loose wires. So if all these three things are there, they will affect the data definitely. So we should check it. This is sensor accuracy. Network and communication issues. We should ensure Wi-Fi or LoRa module is correctly configured. We should give the correct SSID, correct password of our network, and server settings. All we should do correctly. And in order to check whether device is connected to the internet, or we should run the ping command in a command prompt. So use serial monitor to debug the we should use the serial monitor to check the real-time communication data. Then actuator testing, pumps and valves. How to test? Manually, we should trigger the actuators such as a solenoid valve or water pumps using test code. First, we'll write the code, and we should check it whether the valve is opening or not, or closing or not. So by manually, first we should check. Then we should use it in a field and verify if relays are functioning. Sometimes relays will not work. So we should verify whether they are working or not, and whether actuators receive the proper voltage. So using multimeter, we can check the voltage. Then cloud configuration and data issues. We should do the cloud configuration, that is Firebase, AWS, Azure, to make sure the data is being transmitted and received correctly. So and if check if the cloud storage is full. Sometimes the cloud storage will be full, the data will not be sent further. So we should check whether it is full or not, and verify the synchronization between the devices and the cloud systems. And software debugging, use serial log statements in a microcontroller code to monitor the system behavior at a runtime. Use debugging tools. We can use Arduino debugger. We have platform IO to trace and fix the logical or syntax errors in the code. So in this way, we should check the software. We should check the cloud configuration. We should test the actuators, pumps and valves. We should check the communication, network and communication issues. We should check the sensor accuracy. So if you write all these points, it will carry 6 marks. So this diagram, no need to write in exam. They have not asked the diagram. But if you write and explain, definitely you will get 10 on 10 marks. So just by seeing the diagram, the valuer will understand. We have understood the smart irrigation system completely. So they will give you full marks. This is all about question number 9B from May 2025 question paper. So I have done many videos on this May 2025 question paper. You can check my playlist. Different year question papers I have solved, and you can study the questions from different question papers.